All right, I think we're recording. All right, so first question says find the distance between each pair of points and find the midpoint. So there's two things for each question. So distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And all of it is under the radical. So first thing we're going to do is we're going to label. So x1, y1, x2, y2. You could have flipped it if you want. It doesn't matter. As long as you're consistent. So you could call this x2, y2, x1, y1. Doesn't matter. But basically all we're going to do right now is plug it in. So we're going to take x2 minus x1. So we're going to do 2 minus 5. Make sure you put parentheses squared plus, and we're going to do the same thing here. Y2, 1 minus 4 squared. And then we're going to figure out what that is. So 2 minus 5 is negative 3 squared plus, what the hell am I doing? Why did I do that? Anyway, so over here is going to be 1 minus 4, which is negative 3 again, squared. So now we're going to evaluate it. So the square root of negative 3 squared is 9, plus negative 3 squared again is 9. So that's going to give us radical 18. So that's the distance, but we could break that down into radical 9 times radical 2. Radical 9 is 3, so that's going to be 3 radical 2. So this right there is our distance between the points. The midpoint of these 2 points, so the formula for midpoint, I'm going to do it here and then I will erase it. So the midpoint formula is x2 plus x1 over 2, and then y2 plus y1 over 2. We're going to put that in parentheses. That's midpoint formula. So now we're just going to go ahead and add the two x's. So x2 plus x1. So that's 2 plus 5 over 2. And then we're going to do the same thing with the y's. 1 plus 4. So 4 plus 1 over 2. Since we're adding, the order doesn't matter. So I could have put 5 plus 2. So this is 7 over 2. That's the x. And then the y is 4 plus 5. 4 plus 1 is 5 over 2. So 7 over 2 and 5 over 2 is our midpoint. So that's our midpoint. Okay. So that's question number 3. Question number 4, if we look at that, that one has something very similar. That's fine. Okay, let's change the color. Okay. So over here, I'm going to do this question in purple. So our distance formula is same thing, right? So we're going to go ahead and we're going to subtract the two x's. So negative 2 minus negative 4, negative 2 minus negative 4. And then over here, same thing with the y's. We're going to do 3 minus 5. So this is going to be negative 2 squared plus, keep change here. So that's going to be negative 2 plus 4, which is equal to positive 2 squared. And so now we're going to evaluate it. So this is going to be 4 plus 4. And so the distance is equal to square root of 8. That's going to be radical 4 times radical 2. Square root of 4 is equal to 2, so it's going to be 2 radical 2 is our distance. Midpoint formula. Midpoint. Again, we're going to take our two x's and add them up. So negative 4 plus negative 2 over 2. And then we're going to do the same thing with the y's. 3 plus 5 over 2. So negative 4 plus negative 2 is negative 6 over 2. And 3 plus 5 is 8 over 2. So negative 6 divided by 2 can be simplified to negative 3. And 8 divided by 2 is 4. So here is our midpoint. Okay, we have a couple more questions. So we're going to do the same exact thing here for distance formula. So distance formula is equal to the square root of, we're going to subtract our two x's, we're going to subtract our two y's, we're going to square them, and we're going to add them up. So we're going to subtract these two. So -5 minus -1, because here's, I'll call this x1, y1, x2, y2. So all I'm doing is plugging crap in. So over here, I'm going to do -1 minus -5. So keep change here again. So -5 plus 1 is -4 squared plus, keep change here again. So that's going to be +4 squared square root. Here's our distance. So now I'm going to evaluate. So -4 squared is 16 plus 4 squared is 16. 16 plus 16 is 32. So that's our distance. And then we can evaluate this into the square root of 16 times radical 2. So the square root of 16 is 4, so it's going to be 4 radical 2 is our distance. Midpoint, again, we're taking the two x's and adding them together. So -5 plus -1 is -6. We're going to divide that by 2, so basically averaging them. We're going to do the same thing with the y's. -5 plus -1 is again -6 divided by 2. So this is going to be -3 comma -3. And this is our midpoint. Okay. Let's do this in blue. So same thing. So distance is equal to the square root of -3 minus 2 squared plus, we're subtracting -4 minus 0. I did this minus this. So I should have done 0 minus -4. But whatever. So 0 minus -4 squared. So this right here, 0 minus -4 is just going to give me 4 squared, plus -3 minus 2 is going to give me -5 squared, parentheses. I'm getting a little bit sloppy with this last one, sorry. So -5 squared is going to give me 25, plus 4 squared is going to give me 16. And then over here I have a square root under it. 25 plus 16 is equal to 1, 2, 3, 4. So the square root of 41, and that can't be broken down further. So there's our distance formula. Midpoint formula is take your two x's, add them. So -3 plus 2 divided by 2, and 0 plus -4 divided by 2. And that can be simplified. So -3 plus 2 is -1 half, because divided by 2. 0 plus -4 is -4 divided by 2. And this can be simplified into -2. So here is our midpoint. Done, finally, with the first slide. Okay. Next one, determine the intercepts and sketch the graph of the given equation. So the intercepts, so to find the x-intercept, you make y equal to 0. So we're taking the y, we're setting it equal to 0. So 0 is equal to 2x plus 4. And then you solve, right? So subtract 4 from both sides. So you get -4 is equal to 2x. Divide both sides by 2. Devote. And this is -2 is equal to x. So here is your x-intercept. Your y-intercept, you find it by setting x equals 0. So it's like the opposite, right? So x-intercept y equals 0. To find the y-intercept, x equals 0. So I'm going to take wherever I see an x, I'm plugging 0 in. So y is equal to 2 times 0 plus 4. 2 times 0 is 0 plus 4. So y equals 4 is my y-intercept. Sketch the graph. So this is going to be a horrible sketch, but this is our slope and this is our intercept. So our intercept is at +4. So 1, 2, 3, 4. So there's going to be a point right here. And then from there, I'm going to go up 2 over 1. So I'm going to go up 2 and over 1. So this is going to be my new point. To kind of go this way, I'm going to go down 2 over 1 to the left. And then I'm going to sketch. This is a sketch. I can't draw for shit, you know this. But anyway, there's a sketch of my graph. And then this one right here, same concept. So determine the x and y intercepts. So x-intercept is where y equals 0. What the hell? Whatever. Can I just move this? Hey. Okay. So I'm going to take 0 here. So 0 is equal to negative 2x plus 5. So I'm going to subtract 5 from both sides. So negative 5 is equal to negative 2x. Divide both sides by negative 2. So I'm going to cancel that out. Negative 5 divided by negative 2 is positive 5 over 2 is equal to x. There is my x-intercept. Y-intercept is where x equals 0. So wherever I see an x, I'm going to plug in 0. So we have y is equal to negative 2 times 0 plus 5. Again, negative 2 times 0 is 0 plus 5, so y is equal to 5. So same concept. So 1, 2, 3, 4, 5. This is my y-intercept. And now I'm going down 2 and to the right 1. So down 2 to the right 1. So this is going to be my sketch. Again, I can go down 2 over 1, and there's my points. I need 2 points to graph a line, but if you want to just be safe, you can continue going. All right, this one right here, so same concept. Oh, hello. Okay, go away. Oopsie. Oopsie. How do I go back? Here we go. Okay, sorry about that. So over here, we're going to do the same thing. So we're going to have our x-intercept is where y equals 0. So wherever I see a y, I'm going to plug in 0 is equal to the square root of x. So to get rid of a square root, I square both sides. So I'm going to get x is equal to 0. There's my x-intercept. Y-intercept is where my x equals 0. So I have y is equal to the square root of 0, which is equal to 0. So y equals 0 is my y-intercept. So now I'm going to go ahead and solve this. Well, graph it, sorry. So I have x equals 0, y equals 0, which is this point right here. If I were to go ahead and plug in another number here, like 4, the square root of 4 is equal to 2. So if x equals 4, then y is equal to 2. 1, 2, 3, 4. So x equals 4, then y is equal to 2. And my graph is going to go something like that. It's going to curve. If I want to try another point, like and said that y is equal to 3 now, 3 is equal to the square root of 9. So x would be 9. So over here somewhere would be 9. And then y would be 3. So that point would be where I'm headed to. Something like that. So again, it's a sketch. Okay, over here. So intercepts first, right? So x-intercept is where y equals 0. So I have 0 is equal to the square root of x minus 1. To solve this, I have to get rid of that square root by squaring. So I'm going to square root both sides. I'm sorry, square both sides. 0 squared is 0 is equal to square root and square cancel each other out. X minus 1, add 1 to both sides, and I get 1 is equal to x. So there is my x-intercept. Y-intercept, same concept, is where x equals 0. So wherever I see an x, I'm going to plug in 0. So y is equal to the square root of 0 minus 1. 0 minus 1 is negative 1. So y is equal to the square root of negative 1. I don't know if you learned i's yet, but so y is equal to I. So to how to graph this, so x equals 1 is going to be a point. So it's going to be from here. And then if I plug in x is 2, like if I have a little table here, here's my x, here's my y. So I know that at 1, when I plug 1 in, 1 minus 1 is 0. The square root of 0 is 0. If I take 2 and I plug it in, 2 minus 1 is 1. The square root of 1 is 1. So 2, 1 is another point. 2, 1. And what you'll see is you'll get something like this. So it's this graph, but shifted to the right one. Okay, good. Moving on to the next. Determine the domain of the function given by the rule. So domain means where it can be graphed. So what I mean by that is if I have a negative under this radical, I'm not going to have a value. It's going to be imaginary, but it can equal 0. So I can have a 0. So I put 2x minus 3 is greater than or equal to 0. So again, what's under here has to be bigger than or equal to 0. The only time that's different is when you have something like this. So here, the denominator cannot be equal to 0, so you would just put the square root of x minus 2 is greater than 0. But we'll get there in a bit. So for this one, determine the domain. So we have to go ahead and solve for this. So again, I'm taking what's under the radical and putting it greater than or equal to 0, and then you just solve. So add 3 to both sides, so you get 2x is greater than or equal to 3. Divide both sides by 2, and you get x is greater than or equal to 3 halves. So there's the domain. Over here, same concept. What's under the radical, we're going to set it greater than or equal to 0. So 5 minus x is greater than or equal to 0. And again, that's because under the radical, I can have 0 and above. I can't have anything less than 0 because it's going to make it negative. So I add x to both sides. So I get 5 is greater than or equal to x. And then if I were to read this, because this is not the way, 5 is greater than or equal to x, this is a little confusing. If you want to, you have to put the x first, so we can actually go ahead and graph it. And so x is less than or equal to 5, so everything basically just switches less than or equal to 5. So we have, there's our domain. That's the same exact thing as this. So if you put this down, it should not be wrong, depending on your teacher, if he's a jerk or not. But anyway, um, this one right here, right? So same concept. We're going to take this, and now this cannot equal 0 because otherwise you're going to have 1 divided by 0. So we cannot have that. So what you want to do is set x minus 2 just greater than 0. Over here, because there was no fraction with the x on the bottom, or the square root of x, sorry, on the bottom, you put it greater than or equal to 0. But here, because it's on the denominator, we can't have a 0 as a denominator, so just set it greater than 0. So now you just solve. So add 2 to both sides, so you get x is greater than 2 is our domain. Here, so there's no radical, so that's good. So what we want to do is find out where the denominator is equal to 0, and that's what it cannot be. So the domain for this can be anything except where the denominator is equal to 0. So the easiest way to do this is to factor it out and then set it equal to 0. So I'm looking for two numbers that add to 2 and multiply to negative 3. So I know that 3 and 1 means that that should be our factor. So x plus 3 and x minus 1 should do the trick. So let's just check that. 3 times negative 1 is negative 3, and 3 minus 1 is 2. So that works out. And now you set each of these equal to 0. So x plus 3 equals 0 is one case, and x minus 1 equals 0 is the other case. Flip the sign, so you get x is equal to negative 3, or you get x is equal to 1. So our two cases that we cannot have are negative 3 or 1. So the domain is all real numbers except for negative 3 and positive 1. I'm not sure if you need to know multiple ways of writing that, but basically it's from negative infinity to negative 3, or it's from negative 3 to 1, and it's also from 1 to infinity. That might have confused you a little bit, but basically this is the answer, and you have to find the one that's equivalent to that. And again, the reason why we didn't put greater than or equal to 0 or anything else like that is because we don't have a radical. Okay, so determine an equation of the line through the points. So what comes to mind when you're doing a question like this is y is equal to mx plus b. So we need to find out what our m is and what our b is. So the first thing to do is to find the slope. So the slope is y2 minus y1 over x2 minus x1. That's the formula for slope to find the m. So now you just plug numbers in. So x1, y1, x2, y2. So you're going to plug numbers in. So y2 minus y1 over x2 minus x1. And then you evaluate. So that's going to equal negative 10 over negative 5, which is equal to positive 2. So our slope is 2. So what we just figured out is that this number right here is 2. So we're going to go y is equal to 2x, because our slope now is 2, plus b. So we want to find out now what our b is right here. So to do that, you take one of the points and plug it in. What I mean by that is this is your x, that's your y. So wherever I see a y, I'm going to plug in a y value. I could use this or this, but I don't like negatives, so I'm going to plug in that 4. So 4 is equal to 2 times x is 2 plus b, and I want to find out what the b is. So 2 times 2 is 4, so 4 plus b is equal to 4. Subtract 4 from both sides and I get b is equal to 0. Right? So our whole equation, this is the final answer, is going to be y is equal to, so our m, we just figured out, is 2. So it's going to be 2x plus our b is 0. So y is equal to 2x. If I wanted to check and see if this is right, if I take my x and I multiply by 2, I should get that number, which is 4. That's correct. If I take my x and multiply by 2, I should get this number, which is negative 6. So our formula works out. I'm going to do the same thing for each of them. So here we have y equals mx plus b. So same concept, right? So to find the m, we do y2 minus y1. So y2 minus y1, 7 minus 5 over 1 minus negative 3. So on the top, 7 minus 5 is 2. 1 minus negative 3 is positive 4. So our slope is 1/2. So m is equal to 1/2. So we have y is equal to 1/2 x plus b. We want to find out what our b is. So again, take one of the points. 1, 7 looks pleasing, so I'm going to take 7 because that's our x, that's our y. Half of 1 plus b, and then I want to evaluate. So 1/2 times 1 is 1/2 plus b is equal to 7. Subtract a half from both sides, and I get 6.5 or 6.5 is equal to b. And so our final answer is going to be y is equal to, our m is 1/2 x plus, and our b is 6.5. So 6.5. If you want to make it a little bit more better, whatever you want to call it, this is a half, so it's 0.5x plus 6.5. So keep everything in like decimals, or you can put everything in fractions, doesn't really matter. Over here we have 0, 0, and 3/2. So this problem is going to be way easier. So our slope, y equals mx plus b. So I know that my b is 0, but I'm going to go ahead and do it the longer way just because I don't want to confuse you. But anyway, So m is equal to y2 minus y1, so 2 minus 0. And then on the denominator, I'm going to have 3 minus 0. So 2 minus 0 is 2, 3 minus 0 is 3, so our slope is 2/3. So y equals 2/3 x plus b. And this is why I was saying it's going to be a lot easier, because I have 0, 0. So here's my x plus b is equal to 0. This just cancels out because anything times 0, and so b is equal to 0. So our final function is going to be y is equal to 2/3, which is my m, x, and then plus 0, which is just 2/3 x. I trust that you could do that. I should just do this anyway. So y2 minus y1 over x2 minus x1. So 4 minus 4 is 0. 3 minus negative 2 is positive 5. So 0 divided by 5 is 0. So our slope is 0. So I'm kind of glad that I did this problem. So y is equal to 0x plus b. So 0x is just 0. So that cancels out. And then we have that y is equal to, so we're going to go ahead and plug in a point. So let's plug in 3, 4. So 4 is equal to 0 times 3 plus b. Again, 0 times 3 is just 0. So 4 is equal to b. So our full equation is y is equal to, our slope is 0, 0x plus our b is 4, and 0x is just 0. So we have y is equal to 4, which is true, right? No matter what x is, y is 4. All right. Let's pause. Well, let's stop and create another video later.